Welcome to our fifth lecture of probability for machine learning series, in which today we are going to cover random variable. So let's go to our tablet screen to discuss more about this topic. So before starting this topic, first write our title of the topic, which is random variable. Random variable. So what is random variable? A random variable is a variable that can take values, but the uncertainty is what value it can take, right? So let me first write this definition so that this concept is clear to you. A random variable is a variable is a variable that can take values, right? But there is uncertainty, uncertainty as to which values, right? So let's see some examples of our random variable. For example, y is, let's say we are tossing, uh, let's say two coins. Okay. So y is equal to number of heads. Heads. So here y is our random variable. Random variable. Why? Because y can take value of 1, y can take value of 2, and y can take value of 0. So what is the probability of y is equal to 0? Note, we are tossing two dice here. It is simply 1 by 4, right? What is the probability of y equal to 1? It is 1 by 2. Let's write 2 by 4 here for the simplicity, for the sake of simplicity. What is the probability of y is equal to 2? It is also 1 by 4. Y is equal to 2 means 2 heads. Y is equal to 1 means 1 head. 1 coin head. Y is equal to 0 means 0 heads. Right. So now let's discuss properties of our random variable. Properties. Properties of random variable. There are mainly three properties of random variable. That is probability mass function, probability mass function. You can also write its notation as PMF. The other property is expectation. Sorry, I forgot. I forgot it. Expectation. E of x. Expectation. And the second property is variance. Variance. In this lecture, we are going to discuss both of these topics. This topic we will discuss in some later part of the course, not this lecture, in the later part of the course. So let's see what is our probability mass function. I'm just writing the short note, but you can get it. I'm talking about probability mass function. First, let's write the definition of this probability mass function, and then we will discuss more about it. So what is the definition of probability mass function? Probability mass function is a function that calculates probability of a specific discrete random variable. Random variable. Okay, so let's read this definition one more time. So pardon my handwriting. Sorry for that. What is probability mass function? It is a function that calculates probability of a specific discrete random variable. In this, it is just like probability mass function. Let's discuss this topic by drawing a graph. Probability mass function of, let's say, one die. We are drawing its graph. Okay. Here are the axis and y-axis. So what can be the outcomes of rolling a one die? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, and it can be 6. Very simple. So let's write here 1, 2, 3, 4, 5, 6. The x-axis is our outcome of die. The y-axis I'm not writing because I don't have space here, or I can write, but I'm lazy also, right? So y-axis is the probability of the outcome. So what is the probability that we roll one die and the outcome is 1? 1 by 6. What is the probability that we roll a die and the outcome is 2? Similarly, 1 by 6. Oh, it is not restructuring it. Similarly, for 3 also, 1 by 6. What is the outcome? What is the probability that we roll a die and the outcome is 4? It is also 1 by 6. Similarly, for 5, pardon my structure of drawing the graph, 6. Okay. This one, you also felt it was very easy, right? Let's draw the graph of probability mass function, PMF, of rolling two dice. Of two dice. So what will be the graph of the probability mass function of rolling two dice? It will not be as simple as this graph. Let me draw it. Handwriting, I have to draw these little probability PMF of sum of two die. Sum of outcome of two die. What will be its outcome? Similarly, as we have drawn in the above graph, the x-axis will be our outcomes or events, and y-axis will be the probability, right? To give some space here, right? Right. So let's start some with 1 or 2. Let's start with 2 because this we also know the probability that we roll a die and the sum is 1 is 0. So let's draw the graph. Let's start drawing the graph with 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. For your comfort, you can also write 1 here also, but let's write 1. No, let's leave it because the probability that two die sum is the sum of two die event is 1 is 0. So let's not draw it. Let's draw this. 1 by 32, 36, 2 by 36, 3 by 36, 36, 4 by 36, 5 by 36, and 6 by 36. Right. So what is the probability that we roll two dice and the sum of the outcomes is 2? It is simply 1 by 6. 1 by 36. Right. 1 by 36. Now, if you calculate the The probability that the sum of two dice is equal to 3 is 2 by 36. So what are those outcomes? Those outcomes are, yeah, 1 comma 1, 2 comma 1, and 1 comma 2. Technically, it should be 3 by 36. Am I missing something? Rolling two dice is 1 by 36 because 1 1. Yeah. For rolling two dice should be 3 by 36, not 2 by 36. Which, yeah, I think so. It should be 2 by 36. 3 by 36. Sorry. Yeah, it should be 3 by 36. Let's read right. Sorry for the mistake. It is 3 by 36. I think so. I may be wrong here. I have to calculate a bit more, but we have to make this video short also. So you understand what I mean to say. What is the probability that we roll two dice and sum are equal to 4? Let's write these events also. No, I have mistaken here. 1 comma 1 is not an outcome, right? It is 2 by 36 only. I just got confused for a little bit. 2 by 36 because 1 comma 2 and 2 comma 1, right? So what is the probability that we roll two dice and sum are equal to 4? Let us erase it so that there is no confusion. It can be, the events are 1 comma 3, 2 comma 2, and 3 comma 1. What is the probability? 3 by 36. 3 by 36. Sorry for that oval shape. Pardon my drawing. Similarly, what is the probability that we roll two dice and sum is equal to 5? You calculate it. It is 4 by 36. 4 by 36. Similarly, for this 6, it is 5 by 36. And for 7, it is 6 by 36. And similarly, for 8, it is 5 by 36. For 9, it is 4 by 36. For 10, it is 3 by 36. 3 by 36. For 11, it is 2 by 36. And for 12, it is 1 by 36. Right? I think you must know to calculate the probability of the sum of two dice. Right. So this is the PMF graph of rolling two die is the sum of the probability of sum of two dice. Right. Let's write the same thing, the above thing. We have drawn it in a form of graph. PMF of sum of two die as an equation. Above we have discussed as a graph. Now we are discussing as an equation. So what will be its equation? Probability that capital X is equal to small x. This is the way we denote PMFs. Okay, is equal to x minus 1 upon 36 for 1 x 6, and this is 13 minus x upon 36 for 7 is then equal to x is greater than equal to 12 and 0 else, right? If you don't believe this equation, we can calculate. So what is the probability that we roll two dice and sum is equal to 1? I think so it is 0. So if you put this in because x is 1 and 1 can be fit here only, not here. So if you put x is equal to 1 in this equation, the probability is 0. 1 minus 1 is 0. 0.36 is 0. If we put x is equal to 2, the sum equal to 2. Thus, we roll two dice and sum is equal to 2. That we all know. Here also we have discussed it is 1 by 36. Let's put 2 in this equation. 2 minus 1, 1 upon 36. 2 minus 1 upon 36, which is equal to 1 by 36. That is very obvious. Now let's put some another number. Let's put, for example, 7. So 7 will not go in the above equation. It will go in the bottom equation. because 7 lies here in the bottom part of the equation. So what is the probability of two dice? The sum of two dice equal to 7. Let's put here 13 minus 7 upon 36, which is 5 by 36. I think so. Oh yeah, 5 by 36. Let's verify it by our graph. 7. No, 7 is coming 6 by 36. What is 13 minus 7? 8, 9, 10, 11, 12, 13. Sorry. It is 6 by 36 only. If you calculate by calculator. Sorry for that. It is 6 by 36. And you can see our graph is also showing that only. Let's take another random number. Let's say probability that we roll two dice and the sum of their outcomes is 13. Now you might be confused because we cannot put 13 here in the above equation. We cannot put 13 here in the second equation. But we can put 13 in the third equation because the third equation is saying if the value is not between 1 to 12, including 1 and 12, the probability is 0. So what is the probability that we roll two dice and sum is equal to 13? It is 0, which is shown by our probability mass function and satisfies this definition. So what was the definition of probability mass function? It is a function that calculates probability of a specific discrete random variable, and it is calculating that. So this is our probability mass function. So now let's talk about expectations. Expectation. So what is expectation? First, let's write its formulation or formula, you can say. Then I will tell you what is expectation. For discrete random variable, expectation, you can write expectation also. I have defined it earlier. E of x is equal to summation x multiplied by p of x. Here p of x is the, let me explain. So what is, first let me explain this formulation. So what is this x? X is the event. And what is p of x? P of x is the probability of that event. Probability of that event. Or you can also write the PMF of that event, probability mass function of that event. So what expectation calculates? You can also say expectation equal to mean. So it calculates the middle value or the mean value. Expectation is also mean. Now, let's take a first. Let me give you a question. Calculate expectation for outcome of one die rule. So you have to calculate the expectation of when you roll one die. So assuming that you don't have a background of the expectation and you are hearing the term expectation in this lecture first, this can be a little bit difficult because you don't have any context about expectation, only the context that I have given, which is very short. But if you have some context or if you know expectation from, I don't know, if you have studied expectation in your classes, I suggest to you to pause the lecture and at least try to attempt this question. For the persons who are listening expectation for the first time, this can be a little bit difficult for you. So I hope you have paused the lecture and at least try to attempt the solution. Let's calculate the answer. So first, let's see the formulation. It is summation of x multiplied by p of x. So x is the event. So the first event, if we roll one die, is 1. What is its probability that we roll a die and the outcome is 1? What is its probability? Simple. It is 1 by 6. Plus, because there is summation, Let's talk about another event, which is 2. So what is the probability that we roll a die and the outcome is 2? 1 by 6. 1 by 6. Plus, what is the another outcome? 3. So what is the probability that we roll a die and the outcome is 3? Similar, simple, 1 by 6. Similarly, we are going to do 5 multiplied by 1 by 6 plus 6 multiplied by 1 by 6. What is this? 1 by 6 plus 1 by 3, or you can write 2 by 6. That is simpler for our calculation. 3 by 6, 4 by 6, 5 by 6 plus 6 by 6. So what is this? 6 plus 5 is 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 plus 2 is 20. 20 plus 1 is 21. 21 upon 6. Yeah, I think so. I am correct. Yeah, I am correct. So let's divide it. 21 upon 6. So it will go by 3. 18. 3.0. 6. 5 is a 30. 3.5 minus 30 is equal to 0. So what is the expectation? E of x is 3.5. This is our answer, or you can write solution. So this marks the end of the lecture. I hope to see you in the next lecture soon.